everyone. Welcome to the Tech Tuesdays webinar on Advanced Scanners session for EDC customers. I'm Rinda and I'll be hosting today's webinar. The presenters for today's webinar session are Gaurav Pathak, who is Vice President of Product Management, and Louis Noel, who is our Principal Product Manager. Before we start this session, let's go through some housekeeping tips. This webinar will be for 1 hour. That includes a 45 minutes webcast, and then we will roll over to live for 15 minutes to answer your queries. You can post your questions in the Q&A box on your screen, and we'll try and answer them throughout the presentation and also to the 15 minutes to the end of the presentation. All dial-in participants will be muted so that the presenters will be able to present without any kind of interruptions. The webinar is being recorded and will be available in the Informatica Support YouTube channel and the Success portal. The link will be shared with you as well. Also, you can put in your feedbacks and suggestions for the upcoming topics for Tech Tuesday webinars in the survey that follows this webinar session. The Tech Tuesdays webinars is a webinar series introduced within the Success portal. The Informatica Success Portal is a micro-learning platform that offers free and unlimited learning to all registered users. The Success Portal lists your success offerings, your customer success manager information, bookings available in the Ask an Expert session, and customized recommendation and content. Here are a few important links that you can go over later that will help you in understanding Informatica products and also help you in your product adoption journey. Over to you, Gaurav and Louis. Thank you.
Thanks, Brinda. Hello, everyone. Thanks for joining us today on this webinar about the new advanced scanner capabilities for Informatica's Enterprise Data Catalog. My name is Gaurav Pathak, Vice President of Product Management, responsible for metadata management and CLAIRE areas at Informatica. Joining me today is Louis Noel Trapadou, who is Product Manager responsible for the Enterprise Data Catalog as well. Now, in this webinar, we'll have 3 important parts. In the first part, I'll briefly take you through the importance of data cataloging and the capabilities of the Enterprise Data Catalog. In the second part, which will be the main part here, we'll do a deep dive into the capabilities of new EDC advanced scanners that are now part of the EDC portfolio through the Compact BI acquisition. And finally, Louis Noel will show you a demo of all of these advanced scanners in action. Without further ado, let's get started. Now, before we jump into the details of the acquisition and advanced scanners, it's worth establishing some business context that drives the requirements for advanced metadata management and data cataloging. These are, on the right side, what you see are the 3 major use cases for which Enterprise Data Catalog is used today by our customers. Self-service analytics, where Enterprise Data Catalog is the Google for enterprise data assets, helps users like data analysts, data scientists find the most trusted, most relevant data set for their analytics needs. And here, we not only help users discover the right data assets, we help establish trust in those data assets by providing information like data lineage, by providing information like data quality, data profiling statistics, and all of that. The second use case is data governance. And here, Enterprise Data Catalog, we tag team with Axon, which brings in the business model, the conceptual model, the logical model with respect to things like business glossary and all the logical data models that are created there. And the Enterprise Data Catalog brings in the physical data model by scanning all of the metadata sources that your enterprise has. Now, the goal here is to track key data elements, make sure that they are governed, they have the best data quality, you can establish data lineage for them, and basically they are under compliance under the regulations that apply to your organization. And finally, the third use case, which is broad metadata management or data asset management use case here, the key capabilities of the Enterprise Data Catalog are ability to extract data lineage from the various different organization sources that move data, that work with data, so that users can do end-to-end data lineage analysis, impact analysis. If something is changing, what are the other data assets that get impacted because of that? What is the transformations that are affecting your reporting matrices, and so on. And again, here, data engineers, data developers, and IT architects are the key end users of the Enterprise Data Catalog. The way we make all of this happen is by, number one, scanning a large number of metadata sources so that we can bring metadata into the metadata repository. Second, we bring in business context coming from applications like Axon. And third, allowing users to add more information on these data assets that is available in organizations today in heads of certain expert users. But with the help of Enterprise Data Catalog, we make that information available to everybody in the organization. This information first goes through our CLAIRE engine, where we do things like structured discovery for semi-structured data. We do profiling and domain discovery. We try to identify what kind of data we are looking at by automatically looking at the data and saying, this looks like a customer ID, this looks like a social security number, this looks like a zip code, automatically tagging the data assets, automatically clustering similar data assets together, recommending the right data assets for right analytics needs. This information goes into our metadata repository, which is a graph database. It's literally a graph database which stores all of the metadata as well as the relationships among them, finally being made available to data stewards, where the associations to business glossary and business classifications are done. And again, here we help with our AI engine by automatically associating the right glossary terms with the right data assets. And that's how all of these three use cases are made possible by the Enterprise Data Catalog. But there are a few technical challenges. And the biggest of them all is the ability to extract metadata from hundreds, sometimes thousands of data sources that are available in the organization. And especially when we're talking about legacy systems like mainframes and some newer cloud enterprise and analytic applications, it's impossible to have metadata coming and getting extracted from all of these systems without native scanners being made available for them. And then here, if you have especially a data lineage use case, where you want to be able to see the end-to-end data lineage going all the way into your end reports. These data lineages are typically incomplete because there exist these black box applications like mainframes, applications that transform data, databases containing stored procedures and then SQL code and scripts and tools like SAS. All of these applications have traditionally been black boxes, making it difficult for data cataloging applications to provide this end-to-end lineage for these applications. This is where our acquisition of a compact solution comes in. With this acquisition, we have now integrated compact solution scanners for stored procedures, for mainframes, for SAS, and for a lot of other systems with Informatica's Enterprise Data Catalog, making all of the detailed data lineage capabilities available in those scanners available to the Enterprise Data Catalog and you who are customers of Enterprise Data Catalog. We now have the broadest metadata connectivity. We already had close to 60 plus scanners available with the Enterprise Data Catalog. And with these new advanced scanners, there will be no black boxes anymore. We will be able to parse stored procedures, we'll be able to parse SQL code, parse SQL scripts, parse mainframe code, and a lot more, providing end-to-end data lineage for customers like yourselves. And we also establish only single vendor metadata management solution. You don't have to go to other vendors to get any new metadata scanners with our broad metadata connectivity. We simplify procurement, deployment, maintenance, support of all of these data cataloging capabilities. So let's, in this webinar, we will explore how we make all of this possible with the new EDC advanced scans capability. Now, you can have the best catalog in the world with the best business user experience and the best AI. It will be still useless to the business if it cannot extract metadata from the most important systems that users care about. With the acquisition of Compact Solutions, Informatica EDC has truly become an enterprise catalog of catalogs. And let me first give you a quick overview of what I mean by catalog of catalogs. A catalog of catalogs helps with extracting business and critical metadata from a scattered data estate spanning multiple clouds, on-premise systems, mainframes, and others. And more organizations have this same challenge. Organizations want trusted data, they want secure data, they want risk mitigation, and there are data privacy mandates. So the urgency to collect comprehensive data lineage that shows not only the provenance from the source, but how and where the data is consumed, by whom, how is the data transformed. All of that becomes very, very important with these new requirements. This is where the acquisition of Compact BI comes in. With the acquisition of Compact BI, we have now introduced advanced scanners that can extract metadata from hard to access sources. Advanced scanners can parse dynamic SQL scripts. They can parse stored procedures in databases, SQL statements that are executed conditionally. These cover the most important flavors of SQL, like SQL Server, Oracle, and Teradata, but also others like Metisa. They cover BI and analytic applications and providers like SAP, SAS, Microsoft, third-party ETL tools, and Mainframe and COBOL code. So with this acquisition, we can provide end-to-end data lineage and impact analysis for all of the different ecosystems and different data sources and metadata sources that your organization has. All of that going to one vendor, which is Informatica, to get all of these capabilities within your enterprise data catalog. So let's look at the metadata connectivity that's now available with EDC. On the left-hand side, you already have all of these scanners that are available with EDC. These are standard scanners for databases, for data warehouses, for business intelligence tools, for Informatica ETL tools, as well as data quality, MDM, and other tools. We can support structured and unstructured data through file formats. We support for big data systems, cloud platforms, and your cloud data warehouses and cloud data lakes and applications. This already includes 60 plus standard scanners that were available. With this new EDC advanced scanners capability, we've now added the ability to parse code, and not simple static SQL code. I'm talking about dynamic code, dynamic scripts that are in databases like Oracle, SQL Server, Teradata, Netezza, DB2, and Sybase to start with. You can now go to third-party ETL tools and extract metadata from there, like IBM DataStage and Microsoft SSIS, mainframe systems, and if you have code, JCL code that's going to that's moving data in your mainframe applications. We in vSAN files and such, we will now be able to parse that JCL code and give you end-to-end data lineage for it, as well as for statistical and BI tools, especially tools like SAS, and here I'm talking about SAS-based. So if you have SAS scripts, with the EDC advanced scanners, we can now extract data lineage from SAS and other systems like SSAS, SSRS, SAP BW, and SAP BW. Let's talk about the key use cases where you will need these EDC advanced scanners. The most important use case for which the advanced scanners are useful for is data lineage. Now, data lineage is a very important business imperative across all of the data cataloging use cases, whether it is self-service analytics, whether it is data governance, whether it is metadata management and data inventory. And here the requirements can come from regulatory compliance, regulations like BCBS 239, GDPR. All of these different regulations require the ability to understand how data is moving, how the important risk matrices are calculated, and how they can be provided to end auditors. These data lineage requirements are useful for data quality initiatives, for data governance to understand again which systems are responsible for key data elements, for data analytics to establish trust in data, and for data privacy and security to know how sensitive data is proliferating across your enterprise. And data lineage is not only just useful for those main use cases, it's also useful for things like change impact and impact analysis. If you're looking at a report and a report metric is showing a number 1 million when the report, the metric should be 100 or close to 100, how do you know what's going wrong? Data lineage helps you go back and look at all the places where data transformations are happening to understand where the mistake happened quickly. Otherwise, it could be a months-long exercise to figure that out. Change management. When you're changing a particular column, deleting a table, or changing the schema for new version of the application, how do you know before you do that, what are the end reports that will get affected? Who are the end users who will get affected because of that change? And change impact analysis helps you in identifying that by providing this end-to-end data lineage diagram. It helps with operational efficiency, finds out where duplication of data is happening, how sensitive data is proliferating, how you can delete some of the redundant data from your organization. It helps with cloud modernization. So as you're moving data to the cloud, you can understand what sources are used for what targets in the cloud data, and if the data is properly reconciled with things like profiling. And finally, even for AI and AI governance use cases, you want to understand your training data is coming from the right sources, they have the right data quality, and are sourced from the right data sources that can be trusted. And again, data lineage plays a big part in that. So advanced scanners, the key capabilities that they add to Enterprise Data Catalog. Number one, we can now parse code from stored procedures, SQL scripts, and multi-vendor ETL tools like IBM Data Stage and SSIS. These systems are no longer black boxes. We can automatically obtain lineage and data relationships at a very large scale. So even if you have thousands or tens of thousands or hundreds of thousands of stored procedures inside your databases, these advanced scanners will be able to extract lineage from them. We will be able to extract deep metadata from not only static code, we can now extract metadata from dynamic code with heavy parameterization to provide accurate lineage. We will not skip stored procedures or SQL scripts that are parameterized. Instead, we will be able to take those values and provide the right data lineage for that code. And finally, we provide complete visibility into the procedure calls. We decompose the SQL statements based on the conditional paths that they are taking and provide that view into the data lineage diagrams as well. Let me quickly show you how some of those capabilities work. And then before we go into the advanced scanner capability, I think one question that you may have in your mind is, how do standard scanners differ from advanced scanners? Now here we have scanners, we already have standard scanners for Oracle, SQL Server, Teradata, NetEase, Sybase, and DB2. So for extracting simple object metadata like tables, views, synonyms, standard scanners are mandatory, so you can continue to use those standard scanners. Where advanced scanners come in is when you have the requirements for extracting lineage metadata from objects like stored procedures, wherever you're calling functions, triggers. All of those data lineage use cases is where advanced scanners come in. And in those cases, in addition to your standard scanners, you need advanced scanners to be able to parse that code and get lineage from there. So let's do one more level of drill down into what does that mean between standard and advanced scanners. So standard scanners bring in object metadata like tables, views, relationships between views and tables, synonym to tables, materialized views. All of this information gets in already in EDC through the standard DB scanners. We also support some lineage like views and synonyms to tables is supported. And for certain select databases, we also have what we call the script scanners like Oracle, Teradata, Hive, and DB2. But two things to remember. Number one, the lineage that we give are not, they don't, these script scanners don't support stored procedures on anything embedded in the database. It's only external scripts. Number two, the lineage that comes from these standard scanners are at the table level only. This, I'm talking about the script scanners here. So we can't, with those script scanners, we can't go all the way down till the column level and give you that level of lineage. And of course, with standard scanners, profiling is available. Now, where advanced scanners come in is the ability to extract lineage by parsing stored procedures, functions, triggers, everywhere you have SQL, even scripts. But when we talk about scripts in advanced scanners here, we are talking about really deep lineage by looking at the SQL statements and provide it at the field level. There is advanced visualization available for complex SQL. I'm going to show you some of that, both in the slides as well as the demo that Louis Noel is going to show you. We support dynamically parameterized SQL with the advanced scanners as well. So here, lineage is supported from database scripts at the column level as well. So detailed lineage at for tables, views, synonym. If you have like a select star, we are able to understand what what does that star mean on both the source and target side and connect it at the field level. So you see that end-to-end lineage. So basically anything, if you have a data lineage use case, for for any of the regulatory compliance, and you have a large number of stored procedures that you want to support for impact analysis, change impact use cases. Standard scanners will provide simple object metadata, but it is advanced scanners that will be able to parse the SQL code, parse these stored procedures, and provide this end-to-end data lineage. Let me show you some of that. So dynamic SQL is supported with advanced scanners. So if you have stored procedures that are static, we will be able to parse them, of course. But if you have dynamic stored procedures where you have parameterization, you could have parameterized connections, you could have parameterized source tables, target tables, you could have parameterized the entire SQL statement itself. With this new advanced scanners, we will be able to take in those parameterization values and will be able to provide you end-to-end data lineage. And in real life, most SQL code is dynamic. It's heavily parameterized. So if you have databases that have stored procedures, you know that, right? And then that's where advanced scanners come in, and we support accurate data lineage extraction from all SQL code. There's no black boxes for COBOL, JCL, SAS. For SAS scripts, we have done a webinar with our customer Westpac New Zealand, where they showed how they parsed SAS scripts and were able to extract data lineage, which was the most important regulatory compliance use case for them. And we can do the same thing with COBOL, JCL, mainframe systems, and provide end-to-end lineage for it. We can provide lineage for SSIS, SSAS, and SSRS. We can, if you have SQL stored procedures that you call from SSIS, we will be able to go to those stored procedures, extract end-to-end data lineage, and give you a full view of your data lineage here. If you're calling and embedding SQL inside SSIS or SSAS, SSRS, we will be able to parse those and extract lineage from them as well. Same with IBM data stage. If you're calling stored procedures from IBM data stage, if you have jobs, if you have embedded SQL, so this scanner will be able to completely extract data lineage from jobs with or without SQL. It will be able to, in most cases, customers also have stored procedures getting called from these IBM data stage jobs, and the advanced scanners helps with those lineages as well by not only looking at the job lineage, but also going to the stored procedure and extracting lineage from there. So for all of these capabilities that I talked about, it's not only just extracting data lineage at the column level, we actually go a level down. For those stored procedures, we also decompose those SQL statements into individual transformations like filter clauses or when clauses or what the updates are happening. So when you're looking at this data lineage, you can drill down into this advanced visualization and you can analyze your stored procedures in more detail. So for all of those use cases, whether it is regulatory compliance, root cause analysis, impact analysis, or data migrations, you will be able to see this detailed level of lineage for all of your stored procedures with the advanced scanners. And there is another capability that we've added with this advanced scanner, which is called the Advanced Custom Metadata Loader. A lot of our customers have use cases for loading custom metadata, which is object metadata or lineage metadata, into EDC. And with the Advanced Custom Metadata Loader, we have made it more user-friendly to ingest custom metadata into the data catalog. And what it does is most users already have a certain pre-formatted Excels where this custom metadata is stored. So it may be for lineage kind of information, you may be storing this information as an Excel where you have source data, target data, transformation. What Advanced Custom Metadata Loader does is you don't have to change your Excel format. You can configure the Advanced Custom Metadata Loader to expect that format. And then from there on, you can just keep updating your Excel and sending it to this Advanced Custom Metadata Loader, and it will continue to fill this information in and add this information to EDC. You can keep this custom metadata in relational databases, Excel spreadsheets, or XML, JSON, CSV files. There is no development required. Once you've done the configuration, you can keep sending these Excel spreadsheets into EDC. And that way you will be able to get end-to-end data lineage even for the custom metadata for the scanners and then systems that we don't support out of the box. So what does advanced scanners give you? In summary, it scans everything, including stored procedures, mainframe, ETL, BI, no black boxes. It goes very deep. Every single transformation, every piece of logic, and all of that is decomposed into, if it's a SQL script, it's decomposed into its constituent elements so that you can understand how this data is getting transformed. You can trust, because there is no, we are not skipping stored procedures. We are not, for things that we don't understand, for things that are parameterized, we don't skip those and then move ahead. We actually go ahead and provide clear information about how lineage, how data flows through those stored procedures. And lineage being a critical part of the data governance story, EDC can now provide this complete data governance platform. And just like profiling or glossary, with these new advanced scanners, data lineage, it is now complete for all of the different sources that we see. With that, let me invite Louis Noel to give you a demo of some of these advanced scanners as well.
Thank you, Gaurav. Let's now go over the demonstration of the advanced scanner in the Enterprise Data Catalog. So here I'm going to look at end-to-end lineage generated using the advanced scanners in EDC. Let's start with looking for reports that I have used and seen in my reporting tool. Here in this case, we are using SSRS. And we are looking at a particular report that brings information about freights and tax per month for the reseller of our products. Here in this case, we see the details of a report, the different fields that are available and shown in this particular report, as well as some of the layouts available. You see the text box etc., that are available, and the fields that display metrics and attributes. Let's continue with the lineage information, which is the most important part here in the case of the advanced scanner, as we are able to extract meaningful information from the flow that generate these reports. Here you can see that the report shows on the right side of the diagram. It's based on different sources and goes all the way to source systems. And we see here information about SQL, MS SQL database. We see also information about coming from SSIS, and in the middle we have another SQL Server database and another analytical service, SSIS. As you can see, I can expand everything. Here I can see that this particular report is based on a data set, and this data set is based on various components that comes from the SSIS, the analytical tool from Microsoft. I can look at the details of the cubes that are used to build these particular data sets, the dimensions. It uses the product dimensions. It's using the measures coming from reseller sales, measure groups, and I can even go and see what are the data sources for those particular elements in SSIS. And those data sources point back to the tables in our MS SQL Server database. Now I can see all this lineage, which is great to see the end-to-end lineage, but I can also go deeper and look at the column level information. I can go down, for instance, and look at the freight and tax amounts that are related to those sales of products. And I can see that all across those various systems, I can find the different data objects and data elements that are impacted or used within the lineage of those assets. Can expand everything once again and see what are the different ops of those items in my systems. Now, if I look at an object in the MS SQL Server database, I can see that I have various sources, some that are coming from within the same database, but some that are coming also from the OLTP database. So here, if I look a little bit more at the details that I have here, let me expand everything. I can now go deeper and look at the transformations that are available in the system. So if I'm interested to look at how this particular product dimensions table is loaded, I can click on this orange dot, and it's going to bring me the information on how this information is loaded. Here I can see in particular that I have a SSIS data task. I will click on it and look for specific details that are I can access here. So I can see here that it's a data flow, and I can see that there are various calculations that are available in this data flow, and I can even go and look in further details about all the steps that are involved in this data flow. I can see that it comes from various files that are used to load these particular tables. I can see that there's aggregate conditions that are used here. There's many files that are, many fields that are used for the aggregation. Here we see that euro information is concatenated. Here the ID is concatenated for particular information. I can also see what is happening in this conditional split. I can see that for this particular information, we load two objects, one which is the DIM product, and one that is the DIM product filtered, and the DIM product filtered will correspond to the objects that have a color field sets to NA. Now let's go back and look at our process. So we've seen that there's details about SSIS jobs, and we can go all the way down to the transformations that are applied within those SSIS data flows in EDC. And all of that is done through the advanced scanners for SSIS, and we can continue and look at here. I'll go back to my factory seller sales table, and I can this time focus on how this particular factory seller sales table is loaded into the data is loaded. And I can see that in this case I have stop procedure that loads this particular table's factory seller sales. If I'm interested, I can go down to the level of the statements that are executed as part of those as part of this particular stop procedure, and understand what are the transformations that are applied to load the data into the factory seller sale. Let's go to the overview page. I can see all the fields and calculations that are available within the transformation statement. And if I go down to the system attributes, I can of course see the statements for in detail, and I can go these particular statements in a more advanced fashion. I can see the full query that is executed, and I can look at additional information. For example, I can have a full report of the mapping for the different fields that are involved in these particular statements. It tells me what are the transformations that are applied for each of the fields that are given as output. It gives me the different source columns, the different target columns, as well as the conditions that are applied for this particular calculation. We have also a visualization that is available here for these statements. So here in this case, there is a lot of tables that are involved in the journey statements with the work condition. As you can see, the work condition is here, and as we are joining all those objects, we can look at the work condition in particular and see what is happening here. We can see that there's a filter on the last load date that comes from another function that is executed and called the get load date, and that is given by the maximum date of a particular table. So here, if I can see this load control object is used to as a parameter for the get load date. The get load date is returned to filter the records that I'm extracting and loading into the target object. That concludes the demonstration for the SSIS and stop procedure parsing, as well as SSIS and SSRS advanced scanners. Now we'll look at a demonstration of how we are able to parse complex processes from a mainframe system. So let's first look at particular JCL jobs that coordinates the execution of many tasks to achieve building customer rating report in a mainframe system. So here in this case, you can see that we have different steps within this JCL job. Here we start with executing a job that is called unload control statements. So here in this case, we have JCL statements that execute this unload action. Then here we have these particular sections that will also execute another unload command the system to generate the filtered customer file. Here before we were generating the customer file from this unload control statement. Here we have a JCL command that is executing another task. This step is here to sort the input file, one of the input files. So we are taking the customer files that we generated before, and we are sorting it, and we are naming this file customer file sorted. Right. This particular step will prepare the data and execute prepare the data of another data set for the SAS program. So here we are unloading some of the data into from the table customer data legacy, PL customer legacy, and writing it into the proc data customer legacy file. Finally, here we have we continue and we have a SAS program execution. This SAS program will take the two legacy input files and the sorted files to generate a new customer file with ratings associated with it. So we have this SAS program that will take the values as inputs and will generate the rating tables for the customers. We continue here. In this case, we want to load back the results from the SAS program, and we'll load it back into the table customer PL with using this particular statement. So we are loading into the PL customer tables to replace what we had in at the beginning of the job. And then we'll have a COBOL program that will generate reports here that will be called the summary file. And then finally, we'll load back again the information into the PL-based customers and into the mainframe table. Now let's look at this job in EDC. So let's go back to EDC and search for the demo job. The CL program, so we can find this demo job has been loaded into the catalog using the advanced scanner for Mainframe for JCL and COBOL. And in this case, this particular advanced scanner combine all the three capabilities. This demonstration combine all the three capabilities: JCL, COBOL, and SAS program execution. Let's drill down into the demo job program. Here we can see multiple steps, the different steps that we just described through the JCL program. We can see the include statements that happens at the beginning. We can go into the details of these statements. We can see here that the snippet of the code is taken out of the JCL COBOL file, the JCL file, and put in here as the source code. You can go and visualize in more detail this particular code snippet. Here we have again the code snippet associated with this particular step. We can look at the mapping. We can see that the ID field and the name field are being selected, and the where conditions that is used to extract the data when we are unloading the data from the PL customer tables. And then a visualization is available as well to see how this goes from PL customer tables to customer.file in the Mainframe system. We can continue the exploration by looking at contains. So it contains the calculations like we have seen for other objects, and we can continue and see also what is the full lineage for this particular step. Here we have the include steps that unloads the data from the PL customer objects, and we can fully expand this. In this case, we have the sort step that is executed on top of on this particular customer.file that becomes the customer.file sorted. And we continue, and on this customer.file sorted, we have the CM report COBOL job that is executed, and this CM report generates two files actually. That one it goes back to the PL based customers and some that are used for further processing. On the source, we can see that we have the PL customer table that is updated by previous processing, and this processing is actually corresponding to the SAS steps that we have seen. So here we can see the PL customer legacy tables that is source of the second step in the JCL program that generates the file, customer legacy file, and this file is fed to the SAS program here for bringing back the ratings that is necessary for the file. Those ratings are directly coming from the SAS system, where you have two files, customer legacy dep and customer legacy rate, RAT, that brings the rating here into the objects. As always, you can drill down at the column level and see how all the steps that are involving those different columns in the job execution of the program. So all these details allows you to follow down the full life cycle of the data in the catalog. So here we can get into the details of this particular COBOL program, and it's calculating the CM report is calculating a total value that is available here. If we go down to this column and look at the source of this total, we may be able to, in this case, we can see how the total is calculated. We can see that it's coming from CM report. Let's navigate to CEM report COBOL program. So here you can see the description. We can see that it's decomposed in different paragraphs and the different calculations that are available in this COBOL report. We can look at the details, what is the code that is executed, and of course we can look at the visualization. Here the visualization that is available for this particular COBOL program, the CM reports.cbl. You can see in this case that the total amount is calculated from the PL customer objects by summing the amount of that object. The PL transaction, sorry, of that particular table. So looking at the total amount spent by the customer, we can derive the best customers. And as usual, we can look at the full visualization of the job. The SQL component is completely, the SQL query is completely decomposed in multiple steps, sort steps, the aggregation steps to show how we are calculating the actual value here. In this case, the sum of the amounts multiplied by the price of the particular objects coming from, or the particular field coming from PL transactions. That concludes the demonstration of the mainframe capabilities, parsing capabilities for EDC. We can see that now we are able to extract metadata from very complex systems. We are extracting metadata from JCL program. We are extracting metadata from COBOL programs and SAS programs, all of that, to allow us to create a very complex lineage information about how the data is flowing through the different programs in the mainframe environment. With that, I'll thank you all for joining this webinar, and we'll hopefully have answered a lot of questions that you may have about the advanced scanners. Thank you.
Hi everyone. If you have any queries, please post your questions in the Q&A box. Gaurav and Louis will answer you.
While you do that, thanks everyone for participating in this webinar. We got about 40 questions from all of you, so definitely a very, very interested audience. So thanks for that. We've answered most of your questions here. I'll try to, for some of the repeated questions, I'll repeat them here. Things like, what version of EDC do we have the advanced scanners available? So the version is EDC version 10.4.1.1. With that version, you have all of the EDC advanced scanners that are available that we talked about today. Some other questions, a lot of questions about licensing. Please work with your Informatica rep. They have the latest details on the licensing. EDC advanced scanners are separately licensed, and they'll give you the latest information on that. There are other questions on the capabilities of EDC advanced scanners, like can they scan stored procedures, functions, and get metadata lineage from there? Yes, these EDC advanced scanners are designed to extract deep metadata lineage from stored procedures, functions, triggers, SQL scripts, etc. So they will be able to parse the SQL code in there, get you the detailed lineage information like the way you saw today. Other questions, do advanced scanners support source SQL and stored procedures that have been called by SSIS and data stage? Yes, the answer to that is yes. So if your data stage jobs or SSIS jobs are calling stored procedures, have SQL embedded in them, advanced scanners will be able to parse them and provide end-to-end data lineage. Does advanced scanner support Workday? We already have a standard scanner for Workday, so you should be able to use that. You don't need an advanced scanner for it. Questions on installation. We have EDC 10.4.1.1. Do we still need to install advanced scanners? Yes, advanced scanners are a different installation. You need to first get the license, and then you'll be able to install advanced scanners for the sources that you are looking for. List of all the advanced scanners that are supported. You saw the list. There are about 16 advanced scanners that are now available. You should be able to see this list on informatica.com. We also have a data sheet that's available for advanced scanners that will give you all the details about the capabilities of the advanced scanners. And as I said, please work with your Informatica rep for more details in case you want additional demos and you want to see the advanced scanners working with specific technology. Please reach out to them, and we are very happy to help. More questions. If we have custom lineage already available in Excel files, will EDC advanced scanners be able to pick that up? There is this new EDC advanced custom metadata loader that allows you to ingest custom metadata from Excel files. So a large number of our customers already have this lineage metadata captured in their Excel files, including transformation logic. So the advanced custom metadata loader makes it easier for you to ingest this custom metadata into the data catalog without you having to change the format of the Excel file. So it makes it very business user friendly to ingest this metadata into the data catalog. More questions. Can we scan SQL scripts that transfer data from one database resource to other resource through files, and then can CTL files also be scanned? Louis Noel, do you know the answer to this one?
Sorry, can you repeat the question?
The question is, can we scan SQL scripts that transfer data from one database resource to other resource through files, and can CTL files also be scanned?
So yes, if you have scripts that are transferring from one database to the other, yes, we are able to parse them and connect the two databases together. As for CTL files, we may need to differ on the question and get back to the requester.
Thank you, Louis Noel. Other questions. Documentations on how to configure advanced scanners. These are available with the advanced scanner install, and we will be happy to send them across to you. There are other questions on whether advanced scanners support other sources than the ones that are listed, like unstructured data or Tableau, Prep, ETL, etc. So today, advanced scanners are the ones that you saw on the screen, those 16 advanced scanners for stored procedures, for modules like SAS, for mainframes, COBOL, JCL, for SAP BW for HANA, and SSAS, SSRS, Microsoft SSIS, IBM Data Stage. Those are the scanners that we support today. We plan to expand to more sources in the future. Let's look at other questions. If the code has push-down optimization, Teradata BTEC scripts embedded into ETL jobs, does it scan and provide lineage? So these advanced scanners are available for certain sources. Like in case of ETL, the advanced scanners that we have available are for IBM Data Stage and SSIS. and they will be able to parse these SQL scripts and will be able to provide end-to-end data lineage for that as well. If you have access to source data, is there still a need for advanced scanners? The need for advanced scanners is all about parsing source code and extracting data lineage. So if you have access to source, let's say it's an Oracle source, with the standard scanner, you'll be able to get table metadata, view metadata, column metadata, and such standard metadata available in the data catalog already. What advanced scanners bring to the table is ability to parse the SQL code, dynamic SQL code, static SQL code, and provide lineage from stored procedures, functions, triggers, and SQL scripts. Will advanced scanners also work for enabling reference resources options? Do reference objects work with advanced scanners as well, Louis-Noël?
Yes, it can bring additional objects that are not pre-scanned by the catalog. And so in this way, it supports reference objects. However, if you also have scanned prior to that the objects from the source database or the source file system, you can already link the objects using the advanced scanner as well.
Thank you. Does advanced scanner support Java code? Not yet. We don't support Java code and some of the other languages, but we are looking at expanding, as I said before, the advanced scanners to things like PySpark and other such languages in the future. I think that's a list of all the questions that we have, and I think we are on the top of the hour as well. Thank you very much for joining us on this webinar. Please reach out to your Informatica reps for any additional details on advanced scanners. Thank you very much.